Hey everyone, my name is Mike Peritz, and thanks for being here. I'm going to talk to you today about something you may think you know a whole lot about because we did our junior phase and covered a lot of this stuff, but I think you're going to find there's a lot more to it, and that's handling asynchronicity in JavaScript. So the scope of my and plan of this talk is I want to give you guys a really high-level overview of what asynchronicity is in JavaScript, and yes, how to handle it, but I also want to give you guys resources to use in the event that in your projects later in our semester, and when you become a fully fledged developer, you can come back to this, this presentation if you ever run into anything that's confusing you regarding asynchronicity. But first, I want to talk about pizza. So, did you guys know that there's actually a synchronous and asynchronous way to get pizza? Cool, right? So what's the synchronous way? Well, the synchronous way to get a pizza is to take 30 minutes and make a pizza from scratch down in your kitchen. Whereas the asynchronous way would be to order a pizza for $20 from a restaurant, and you can get a whole bunch of stuff done while it arrives. Neat, right? So what's the difference? The difference is that synchronous events occur step by step, and they block out your day, and you also know when things go wrong. You know when you get an error, so to speak. You might burn your pizza or drop it on the floor or something terrible like that. However, asynchronous events occur in the background, so your asynchronous pizza, you don't know when something's going to go wrong, right? Maybe the pizza guy drops your pizza on the ground. You would never know, right? So, nailed it. More technically, asynchronous events are unpredictable, right? And there's a lot of different ones in JavaScript that we've all encountered so far, such as keyboard and mouse click events, key up, key down, things like that, reading or writing files to your hard drive, accessing the database, HTTP requests, AJAX requests, all these things are asynchronous events. And they take place in parallel on the event loop, and then they push onto the call stack after our synchronous code is completed. We all know this. So why is that hard to handle? Well, what if one asynchronous action depends on the result of another? We would need that to behave synchronously then, right? Because we can't guarantee if they're happening in parallel in the background. So we use nested callbacks, and we all know where this is going. It's going to lead to callback hell, which is really bad. We don't like that. It looks like this, and basically it's borderline unreadable, error handling becomes difficult, and there's got to be a better way. And there is, and it comes in the form of promises. So we know that promises represent the eventual result of an asynchronous action. Basically, promises guarantee that an action will either fulfill or reject, and they have three main components. There's the asynchronous action, which is called and performed when the promise is created, and then there's these two resolve and reject functions, which basically tell the promise what to do in the event that the action is fulfilled or rejected. And it gives us these useful methods like .then, which is going to return another promise, and then we can chain these promises and manipulate the values that we get from them. And we also have easy error handling with our .catch method. So that takes the callback hell code that I just showed you before, and it turns into this. It makes it much more readable. This is nice. We also know where our error handling is taking place right down in that .catch, and it's much cleaner and less verbose. So we're happy now. So what's the catch? No pun intended. Well, promises actually do have some flaws. One of these is that they only represent a single value. So for any additional values we need additional promises. Also, native promises, and I'm not talking about things like bluebird promises, native promises are guaranteed to either resolve or reject. That's probably a good thing, right? But maybe it's not in the event that you have a super big file that you want to pull in from a database. That might take up a lot of system resources, and if you decide you don't need it, you have to wait for it to resolve. So it means they can't be canceled. We also have no ability to control how our values arrive with time, because it happens automatically. So we can't change how our responses arrive with time. So what do we have at our disposal to help us with this? Well, we have streams in Node.js. So what's a stream? A stream represents multiple values resulting from an asynchronous event. So rather than promises which represent only one single value, streams represent multiple values arriving with time. It allows us to break large blocks of data into small chunks, which increases the efficiency of our allocation of memory and resources. And that results in shorter wait times for users when requesting files, which improves our user experience, right? We don't have to wait for a big video file to arrive if it's going to arrive in pieces. We get access to those pieces. And we can also cancel streams midway through. So we don't have to wait for that 5 GB movie to arrive. We can just get it piece by piece. That's sort of the idea behind Netflix, right? And they have this nice simple syntax. This is just a really simple stream that's going to read the data.txt file and pipe it into the res variable. So there's 4 types of streams. There's readable streams, which are the source of your data. There's writable streams, which is where you want your data to end up. And something really cool about writable streams is they allow you to throttle the inflow of data so you can have more control over how data arrives with time. There's also duplex streams, which are both readable and writable, and they can communicate with each other. And a really classic example of this would be a transform stream, which allows you to perform operations on data as they pipe into the target. So you could have a readable stream, enter a transform stream, manipulate the data, and then pipe into the target. And then there's something you should know about. There's also a 4th type, which is the classic stream. These are a little bit outdated, but you may run into them in your work. And they're basically just event emitters for on-data events, but they're pretty outdated. So what are some issues with streams in Node? Well, what if you need to manage and transform lots of streams? Things can get verbose. We don't have a lot of methods at our disposal to help us manipulate and merge and concat and do various things with all the values coming in from streams. So it would be nice if we had some special library or methods to help us with that. What about more control over timing? Well, we know that streams can be throttled. Writable streams can throttle the data that comes in, but there aren't a ton of tools at our disposal. And then finally, what about using streams with React and Redux? Well, we have to manage state, and I'm sure you can imagine that if you're having lots of data coming in, different values over time, it could make managing state really difficult. So how do we deal with this? Well, there's this relatively new idea called reactive programming, which is basically just a functional programming paradigm, and it utilizes streams. It has these useful libraries like RxJS and Bacon.js that abstract out a lot of the implementation details of streams, which results in much more concise asynchronous code. So there's the symbol for RxJS, which is the language I chose just to sort of dive into this. But so yeah, that is one implementation of reactive programming, and it uses observables, which are literally just streams. They're streams of 0, 1, or more values. You can create them from pretty much anything. So you could actually create an observable from scratch. You could create them from arrays, values, promises, objects, pretty much anything you can think of. And then it gives you this Lodash or Lambda-esque method library to manipulate the values that come in, and you can also manipulate how the data values come in with time. It gives you a really large amount of control over how your data arrives with time. And finally, for help in React and Redux and React Redux, we can subscribe to our observables, and we can react to changes. And those changes being new values, errors, and the completion of streams. So just a really quick example. This is basically just some really simple code that is going to append the current mouse position onto the DOM. And we have plain vanilla JavaScript on the top, and then at the bottom you'll see the reactive programming approach using RxJS. And don't worry about the syntax of the RxJS, but surely you can see that it's about 50% the number of lines that the vanilla JavaScript uses. So if you extrapolate that out, you could easily see that this is going to be a useful thing for us. So now let's move on to the future, right? We know how to handle asynchronicity with our methods now, but what's next? So the future is async await, which I'm really excited about. It's set to release with ES7, and it's really cool because it's going to give us direct access to values that are returned from async actions. So what that basically means is we can return values to the window, basically, instead of just using callbacks. And it uses this simple syntax of putting that async keyword in front of a function, and then any asynchronous action you have, you use the await keyword, and then it allows you to return things from that function. But enough about that. That's the future. You can read more about that later. So this is going to be difficult for you guys to read. It's meant more as a resource for you to use, for you to come back to. If you're ever running into a scenario where your asynchronous code just doesn't look right or it's not working. So please feel free to come back to this video and check out this chart. Basically what it says is that the more events that you have that are happening and bringing in values, more data over time, the more likely you are going to be using streams or reactive programming. And then I have a bunch of slides here just on resources that I use that you guys should feel free to come back to if you're running into problems. But that's basically my talk. I hope it was helpful for you guys. And yeah, thank you so much.